class, let's look at 7.2 part 2, now dealing with an arithmetic series. So just a quick refresher, an arithmetic sequence is a sequence in which each term after the first term differs from the preceding term by a fixed constant. We can call that common difference. So we're adding 5 every time, or we're subtracting 2 every single time. There's a common difference, be it addition or subtraction. We could add a negative, or we can just add a number, and that will get us to the next term of our sequence. So now a series is just the sum of the terms of an arithmetic sequence. So we create our sequence, we have all these numbers, we add them all up, and that's called the arithmetic series. All right, so suppose we have the following sequence: 30, 29, 28, all the way down to 1. With a series, we can only find the sum for a finite amount of numbers. So in this case, we started at 30, we went all the way down to 1. But I could also be given a situation where maybe I have 5, 7, 9, ... as the start of my sequence, and they say, well, what is the sum of the first 12 terms? So that means I have some number out here that we could denote in our sequence as a sub 12. Remember, this was a sub 1. So even though it has this ... I've classified it as a finite amount of numbers when I say, okay, out to the 12th term. So we can figure it all the way to that 12th term. So we have to identify some sort of an ending term. Some formula we need to work with. Okay, so S is our notation for a series. So S sub n, where n represents the number of terms in our sequence, is going to be equal to n divided by 2 times a sub 1, which is the first term of our sequence, all the way up to a sub n, which is the last term of our sequence. So this formula is used when the first and last terms are known. So if we know the starting point, we know the ending point, we can immediately jump to this formula and figure out what that sum is going to be. Remember though, a sub n is this formula. So this was going back to our sequence where we have the common difference in arithmetic sequence, a sub 1 plus n minus 1 times d. So this formula that we have in blue can also be written like this. It looks a little more complicated, but it's just taking our a sub n, these are the same, so it's using this in place of a sub n. All right, so not to confuse you, but I'm going to write on the screen here a little bit more. So a sub 1, that's why I have 2 a sub 1s. And then just plus n minus 1 times d, n minus 1 times d. So the second one looks more complicated, but all they're doing is expanding out what a sub n really is. Each formula will work. This one will work every single time. This one, you have to know what the first and last terms are. All right, so getting back to our sequence, 30, 29, 28, all the way down to 1. So let's take out some information that I know from this. Well, I know n, my number of terms, there's 30 terms here. 30, 29, 28, all the way down to 1. Or if I went backwards and counted up, 1, 2, 3, all the way to 30, that's 30 terms. I know also my first term is 30. And I know my last term, my a sub n, which in this case is a sub 30, is going to be 1. This is a sub 30. This is a sub 1. So with that information, I have my choice of my two formulas. I know the first term, I know the last term. I'm going to tackle this one here on the left. So the sum of the first 30 terms, so S sub 30, is going to be 30 divided by 2. A sub 1 is 30 plus 1. And so this becomes 15 times 31, which ends up being 465. I could also use the second formula and arrive at the same answer. So again, S sub 30 is going to be equal to 30 divided by 2 times 2 times a sub 1, which was 30, plus 30 minus 1. My common difference is negative 1. This gets me my 15 again. In my parentheses now I have 60. 30 minus 1 is 29, times a negative 1 being negative 29. So this is 15 times 31, and we end up at the same spot, 465. So again, either formula would work. The one on the left was a little more efficient because we know the first and the last term, but the second one will work as well. Let's try another sequence. So negative 5, or negative 9, negative 5, negative 1, 3, 7. What is S sub 12? So there's some number out here that will be A sub 12, and this is A sub 1. Well, I want to know the sum of all of these numbers. Okay, I can do this without even knowing what that 12th term is going to be. First formula here probably wouldn't use because I don't know what the last term is. That's some blank number. So let's take a look at this. So S sub 12, 12 divided by 2, 2 times my first term, which is a negative 9, plus the number of terms is 12 minus 1. My common difference, well, to get from negative 5 or negative 9 to negative 5, I had to add 4. So my common difference will be a positive 4. When I work all of this out, I end up having 156. So the sum of the first 12 terms in this sequence I can find is 156 without even knowing what that 12th term is. All right, let's find the sum of the first 17 terms of an arithmetic sequence. So that said arithmetic there. My box is kind of in the way. So the sum of the first 17 terms is 187. If they tell me that the 17th term is negative 13, find the first term and the common difference. So on this one, again, I have two choices I can go with. I would not use this first one because I don't know the first term and the last term. I have to figure out what it's going to be. All right. Well, actually, we can use this one. Back up. We can use this one because I know my a sub n in this case is a sub 17. I do not know this. So I can use this formula here on the left, and it'd actually be the easiest, the most efficient one to work with. So this is 17 over 2 times a sub 1, which I don't know, and then plus a sub 17, well, that's plus a negative 13, so let's just say negative 13. So if I were to work this out, S sub 17 I know is 187 equals 17 over 2 times a sub 1 minus 13. I want to divide that 17 over 2 out from this side. Divide this by 17 over 2. Work that out, I end up with 22 equals just a sub 1 minus 13. Add 13 to each side. It tells me that 35 is going to be equal to a sub 1. So now I do know what my first term is going to be. To find our common difference d, I have to look at this other formula because this one has my d in it. So I want to look at, okay, if I only want to work with a sub n. So I know a sub n is a sub 1 plus n minus 1 times d. I'm only going to focus on that part. A sub n is a sub 17. I want to figure out, or I know what the 17th term in my sequence is. This is that negative 13 piece. I know now my first term is 35 plus my n minus 1. Well, this was 17 minus 1 times d. So this is plus 16d. If I were to subtract 35 from both sides, I'd end up with a negative 48 equals 16d. So D is going to be equal to a negative 3. So I was able to find the first term, and I was able to find the common difference without even knowing what the sequence looks like, besides the fact that it's adding up to 187 and what the 17th term is. Working with series, that gets back to our summation notation, which is just adding up all the numbers in our sequence. So if I wanted to evaluate my sum of 4i plus 8 is my function, starting with I equals 1, so I'm going to start with the first term of my sequence all the way out to the 10th term of our sequence. So I need to figure out each of these. So this piece right here is telling me I'm going to start with a sub 1. Well, a sub 1 would be just 4 times 1 plus 8 to equal 12. This tells me I'm going all the way out to the 10th term, so a sub 10, which is going to be 4 times 10 plus 8 to get 48. So I know the first term and I know the last term. So I can use that formula, the S sub, we're going out 10 terms, so it's going to be S sub 10 is going to be, so I was using the n divided by 2, a sub 1 plus a sub n, this formula. So this is 10 divided by 2. First term on here is 12, plus the last term is 48. Work all this out. This is 5 times 60 to get 300 as a final sum. So if we're given something in summation notation with this big E, we can use our formula for a series to figure out what the final answer is going to be, the sum of all of those terms. All right, so this one is going to be due Sunday, 5/3 by midnight. Continue to contact me if you have questions, if you need any extensions on the assignments, if you want to work with me one-on-one, we can do a quick Zoom call. I can work through any problem that you have. Okay, continue working, and we'll keep pushing forward.